Hi everyone. Today we are going to be looking at 6-mark questions and the exam technique that you should use for those longer mark questions. I'm going to start off by giving you some ideas of your approach for these longer questions, and then I'm actually going to run through one from an exam paper to show you this process in action. So, first off, I always say it's worth, when you're doing 6-mark questions, think CUSTARD. Might sound a bit random, but trust me, it is worth following this little acronym. So, what do all these letters actually stand for? So, starting off with C. So, C stands for circle the command word. Command words are usually things like describe, explain, or compare. You also, in those shorter mark questions, like 1 or 2 marks, might see state, but that's unlikely to be a 6-mark question. So next we've got U. U stands for underline the keywords. Keywords that might be important really do depend on what topic you are looking at in this question and the specific question itself. But some things that you might have are things like, does it want to know about alpha, beta, or gamma radiation? Or does it want to know about all 3? Does it want to know about the acceleration of the object? Or does it actually want to know about the velocity? Things like that are the things you need to be underlining to draw your attention to them. Next, we have S. So S stands for scribble a plan. It really is worth planning your answer before you write it. 6 marks in the big scheme of things is actually quite a lot of marks towards your GCSE paper. You do have a fair amount of time to answer it, so you have got time to plan it, and that way you're more likely to include all the details that you need to, as well as putting it in a sensible structure to enable you to get those top marks. So next we've got T, which means think about your structure. So as I said, structure is actually quite important. You do lose marks if you haven't structured your answer in a logical way with these 6-mark questions. So this is your opportunity to decide, does one of my planning points need to go first, second, third, etc. It might be that you've already put it in the order that you would need to or want to, but it also might be you've thought of something at the end that needs to go earlier. Okay, so next we've got A. A is for account for every part of the question. So when we were looking back at the start, we circled a command word and we underlined all our keywords. Now is the time to again look back at those. Have you answered exactly what the question is asking and all parts of it? So if there are multiple parts, you need to make sure you've covered everything. Then, of course, at some point, you are going to need to write your answer. This is the moment that you have been waiting for. You need to write your answer next. I do not have a letter for that one because it's an obvious one. You need to write your answer at some point. Okay, then we've got R. So R is for read through your answer. So once you've written the whole thing, read it through, make sure that it makes sense. In exam situations, it can be so easy to write a sentence that doesn't actually make sense. So reading it through really is crucial. And finally, we've got D. Now D is just for don't rush. So these questions are worth about 6 minutes in an exam, which doesn't sound like very long, but actually it really is quite a long time in the big scheme of things with an exam that's 50 odd minutes long. That's actually quite a long time, and when you're sat in an exam, it also will feel like a really long time as well. So it is worth taking your time over these questions. Okay, next we're going to go on to an example question, and I'm going to run you through what I would do. Okay, so this is an actual 6-mark question off one of the Edexcel papers. If we just read it through first, it says that figure 8 shows two objects Q and R before and after they collide. Then gives us a nice little diagram to look at to show us exactly what is happening. And then it says that the arrows show the direction of the movement and they are not to scale. So in other words, they're not showing forces, which can be something that people make mistakes with. It then says, explain how momentum is conserved in the collision. Use Newton's third law and Newton's second law in your answer. Newton's second law can be written as force equals change in momentum over time. So first thing first, we're going to circle our command word. So in this particular question, our command word is explain. So it's all the way down here, almost halfway through the question. So it wants us to explain how momentum is conserved. Now, we're going to underline our keywords. So keywords that we've got are momentum and conserved. We also need to include Newton's third law, so that's quite important, and Newton's second law. The final thing that it's given us that's useful, even though it's not a key word, is our diagrams at the top. So I'm going to just put a little bracket around that to remind me to look at that diagram. So next we're going to scribble our plan. So this can be just a couple of quick notes in bullet point form. So things that I need to include in this answer. So first things first, we've got momentum. So what's our equation for momentum? That's going to be useful to us. So momentum is equal to our mass multiplied by velocity. Now this is useful because it's told us about the velocity, the fact that this one, Q, is moving, R isn't before, and then afterwards Q is moving and R is. So we're going to need to include that to show that we know what momentum is in terms of this question. Okay, the next thing that we're definitely going to include is Newton's third law, because it says include, use Newton's third law. So Newton's third law is that if an object puts a force on another object, that object puts an equal and opposite force on the first object. So you wouldn't necessarily have to write this much for your scribbled plan. You could just write third law. Then, next step, okay, then our next step would be we need to include Newton's second law as well. So for this, I'm just going to put the equation, so F equals ma. I'm also going to put in brackets, use equation given, because we need to make sure that we include this equation up here as well that we were given in the question. Okay, finally, a couple of points that I need to include is what happens before and after the collision. So for that, I'm going to be talking about what their velocities are before and after, and
what has happened to the momentum before and after. Okay, so I've kind of scribbled my little plan there. Next step is going to be to put that in a specific order. So I'm going to have a think about my structure. So actually, as you write your plan, often you've put it in a sensible order to start with. In my particular case, that's what I've done, because as the ideas have come to me, I've thought about it in a logical order. The idea behind doing this plan is so that you don't just ramble on if you write it all out in one go. So in this particular case, I am actually going to do this part first. I am going to talk about Newton's third law next. I'm then going to talk about the impact that force from Newton's third law has. So I'm going to do Newton's second law. And kind of included within that is going to be this one here. Okay, so now I've thought about my structure. I've got an idea of what I'm going to do. So I need to make sure, have I actually accounted for every single part of the question? So we're going to go back up to this and have a look. So have I actually explained it? I'm not going to just describe, I need to make sure I'm explaining. So I'm not just saying, well, momentum is conserved before and after a collision. So if we've got a collision, momentum is conserved. Because that's not explaining, that's just describing what's happening. Have I said I'm going to talk about the third law? Yes. Second law? Yes. Have I used this equation? I've said I'm going to. So this sort of acts like a little aid memoir for me of what I need to include. Okay, so let's start writing this out then. So we don't actually need to write in paragraphs. We can still use bullet points. That's perfectly fine. So for my first bullet point, I'm just going to state what we did up here as well. So momentum is equal to mass multiplied by velocity. But now I'm going to add something to that. So I'm going to say, at the start, Q has a non-zero velocity. So a non-zero momentum. R is stationary, so has zero momentum. So now I've shown I know actually what momentum is, how I'm going to calculate it, what is this whole question about. Next then, I need to talk about this collision. So when Q collides with R, it provides a force on R. Okay, this causes R to accelerate due to Newton's second law. And I'm going to put in brackets F equals ma, because this is showing if we've got a resultant force, then we're going to get an acceleration. Then next, we're going to bring in Newton's third law. So as Q puts a force on R, R puts an equal and opposite force on Q. This causes Q to decelerate. Now, you'll notice that I've actually run out of space on here. As I said, you wouldn't necessarily need to put as much information in your plan. I've done that to try and show you what my thought process is. But even if you do run out of space in an exam, you shouldn't panic, because you can get another booklet to add some extra detail. So that's what I'm going to do now. Now that we've got Q decelerating, we can start to bring in this equation that they gave us. So as well as F equals ma, they've said Newton's second law can be written in this way. Now this is important because we can link in the forces that we know are existing due to the collision to this side of our equation. So that's what I'm going to do now. So if our force on Q is equal to minus the force on R, which was due to Newton's third law that we've just stated, we can also say that the change in momentum of Q divided by the time of collision is equal to minus the change in momentum of R, again, divided by the time of collision. So our next step is to say that the time taken on the collision is going to be the same for both objects because they are colliding with each other. So they haven't collided twice, they've only collided one time. So the time taken over that collision has got to be the same for each. It's the same for both objects, which then means we can get rid of it on our equation because we can multiply both sides by it. So we get change in momentum of Q equals minus the change in momentum of R. Now, if they're both equal to each other except for this minus sign, then that means that the overall momentum doesn't change, which we knew already at the start because of our law of conservation, but we're trying to explain it, and that's essentially what we've done here. So we can then say, therefore, there is no overall change in momentum. It is just transferred from Q to R. So Q now has less momentum than it did at the start. If we look at our diagram, it's going to be moving slower than it was originally, and R has now started moving and has momentum now. So you've now actually included in that, so my little purple bit, everything you need to get all of your 6 marks. It might look like quite a bit of writing, but you've got to remember you've got to include 6 marks worth of content. The other thing to remember is that you have around 6 minutes in your exam allocated towards this because it's about a mark a minute. And in comparison to some of the other questions, that's a really long time. And in an exam, it can feel like a really long time as well. So that's why we always say, make sure you've read it through afterwards. So In the exam, I would then read through everything I've written and double check, have I included everything I said in my plan? Have I included everything that I said from the question? But also don't rush it because you have loads of time. It doesn't seem like it when we say 6 minutes, but trust me, that is a long time in an exam. So I hope that's been helpful, and I'll see you in lessons next week.